I'm going to introduce an integration shortcut for the exponential distribution in 120A. And if you know the shortcut, you can avoid integration by parts in probably like 95% of the cases, you can avoid integration by parts. So let's begin. I have a problem here. Y followed an exponential distribution with parameter 3. I'm defining x as y to the power of 3. And the question is, let's find the expectation of x and the variance of x. So let me start with the expectation. To find the expectation, we have to recognize that x is equal to y to the power of 3. So we replace x with y to the power of 3. And then to find the expectation of the third moment of y, we have to integrate from 0 to infinity y to the power of 3 times the PDF of y, which is 3 times e to the power of negative 3y. And to find the second moment of x, we want to recognize that the second moment of x is the sixth moment of y. And again, we have to integrate y to the power of 6 times the PDF of y. So the question is it possible to evaluate these integrals? Yes, it is. We can evaluate these integrals by doing integration by parts. However, I would not recommend it. To evaluate the first one, we have to use integration by parts 3 times. To evaluate the second one, we have to do integration by parts 6 times. So there must be an easier way. So alternatively, you could use the MGF, but I do not recommend that either, because for the first one, you have to use you have to take derivative of the MGF 3 times. For the second one, you have to take derivative of the MGF 6 times. So it's not really worth the time. So I'm gonna go ahead and show you an integration trick for 120A. And that's, with that integration trick, we can finish evaluating these two integrals in 3 minutes. And that integration trick is, let's look at the gamma PDF. The gamma PDF looks like this, beta to the power of alpha. So this is a PDF of gamma alpha beta. So the PDF of gamma alpha beta is beta to the power of alpha over gamma function evaluated at alpha times x to the power of alpha minus 1 times e to the power of beta x. And x takes values between 0 and infinity. So if you recall, if we integrate any PDF over its support, we get 1. So what I'm going to do here is I'm going to integrate the gamma PDF all over its support. So I will be integrating from 0 to infinity. And because I'm integrating a PDF over its support, I am going to get exactly 1. And because beta to the power of alpha over gamma, the gamma function evaluated at alpha, because this thing is a constant, let me pull it out. So I'm going to get beta to the power of alpha over the gamma function evaluated at alpha. And the integral from 0 to infinity of x to the power of alpha minus 1 and e to the power of negative beta x. This is equal to 1 because I did not change anything. I just pull the constant out. And the next thing I'm going to do is I'm going to move this constant to the other side. And that's going to give me the integral of x to the power of alpha minus 1 e to the power of negative beta x is equal to gamma function evaluated at alpha over beta to the power of alpha. And this is the shortcut I was talking about. So keep this in mind, it's very convenient. And now let's go back to the question. We are going to evaluate these integrals. So let's look at the first one first. Oh, this integral is equal to 3 times the integral from 0 to infinity of y to the power of 3 and e to the power of negative 3y. I'm gonna let alpha equal 4 and beta equal 3. So as we see here, this integral is equal to the gamma function evaluated at alpha, which in this case is 4, over beta to the power of alpha. So in this case, beta is 3 and alpha is 4. And if you recall from lectures, the gamma function evaluated at 4 is equal to 4 minus 1 factorial. So if you plug this into a calculator, I believe you're gonna get 2 over 9. And let's evaluate the other one. So this integral is equal to 3 times the integral from 0 to infinity of y to the power of 6 and e to the power of negative 3y. So again, in this case, I'm going to use the shortcut. X being raised to the power of alpha minus 1. So in this case, alpha needs to be 7 and beta needs to be 3. And by the integration shortcut, this integral is equal to the gamma function evaluated at alpha, which is 7 in this case, over beta to the power of alpha. So in this case, it's 3 to the power of 7. And again, gamma function evaluated at 7 is equal to 7 minus 1 factorial. And if you plug it into a calculator, I believe you're gonna get 80 over 81. And that's all for the integration shortcut. Definitely keep this in mind. It's very important. So with this shortcut, we don't have to take derivative 6 times. We don't have to do integration by parts 6 times. We just need to plug it into some kind of a formula.